Hey everybody, good to be back with you here at RepliCon. I'm going to be talking today about embedded cluster with the subtitle, What's All the Excitement About? And if you've been at one of our recent RepliCons, we've talked about embedded cluster I think at least the last two RepliCons, we've had some updates on embedded cluster. So today I wanted to share a little bit about where we're at with embedded cluster right now, what are some of the new features we've developed, what things are we looking at on the horizon, and also share a little bit of background on how we got here, why we decided to create embedded cluster, how that compares to kURL, some things like that. So to start, let's review embedded Kubernetes. So what is embedded Kubernetes? Well, at Replicated, this is a term we use to describe embedding a Kubernetes cluster into your application so that you can deploy anywhere, whether or not your customer has a Kubernetes cluster. So for quite some time now, Replicated has supported installing to existing clusters, but also to a VM or a bare metal machine by bringing that cluster along as part of the application, embedding it into the application so that you can deploy irrespective of your customer's environment. So, as I've said, we've introduced in the past embedded cluster, which is a new offering here at Replicated that we've given some detail on in the past. So I'll talk a little bit more about this today. But as part of this, as I've been sharing embedded cluster with a lot of our customers and talking to different people who have been with us for a while, have been using embedded Kubernetes and kURL and things like that, I wanted to share a little bit today about why we decided to create a new project instead of making more improvements to kURL, and why we think that's beneficial and how that's going to work and be worthwhile in the short run and the long run as well. So some background on kURL is that it's often been called a distro builder. And if you've ever been to the kURL.sh website, then you'll recognize this page where you're able to make selections from different add-ons. So you can choose what Kubernetes distribution you want to use, your container runtime, your ingress, and the versions for each of those add-ons. And based on those selections, you get over here your installer YAML, which is a Kubernetes installer specification that you can use with Replicated, for example, in the vendor portal. But there's also this URL, which this is where the name kURL comes from. It's, a kURL command, but it's a Kubernetes URL. So with this one command, pipe that into sudo bash, you can run that, and you get that Kubernetes cluster dictated by that spec that you created with this distro builder. But some of the shortcomings that we've seen with kURL in practice have been, for one, it requires frequent and involved development work from us at Replicated to support new operating system and new add-on versions. So to keep up support for the latest RHEL and the latest Amazon Linux and things like that, all the latest add-on versions, Kubernetes and Valero and the different options that are there, requires a lot of development work. And while we've done a lot to automate those things and make them work, take ourselves out of that work a little bit, it's still maintaining a distro and really maintaining a variety of distros, because you can choose which add-ons you want to include, which takes a lot of work and takes us away from being able to create more features that are going to help you more successfully distribute your application to your customers. As I sort of alluded to there's a lot of permutations, with all the different add-ons we've supported over time and the different versions. And if you were to include the different configuration parameters you could pass to those, you're probably talking tens or hundreds of thousands of different permutations, certainly thousands even if you were to just look at the add-ons and the versions and whatnot. So that makes testing and supportability a lot more difficult for us. And then thirdly, installing and managing a Kubernetes cluster is still a pretty significant part of the end user experience. So as I said before, embedded Kubernetes, the goal is to embed that cluster into the application. But oftentimes with kURL, it feels like you are installing the cluster and then you're installing the application. And then when it's time to update, you come back to the CLI, you update the cluster, and then you go into the admin console and you update the application. So while we are bringing the cluster with kURL, it still feels like a disjointed experience where the end user is still having to operate and manage that Kubernetes cluster. And if they really felt equipped or interested in doing that, they could have brought an existing Kubernetes cluster instead. So we've made strides, I think, to improve on all of these things, but these are some shortcomings that we've seen in working with kURL. And so now let's review embedded cluster, which is our new offering, and talk a little bit about how we got here and how we're addressing some of those problems and why this new project felt like the right direction to go in. So if you've been at one of these talks before, you know that we're re-architecting embedded cluster to be built on the K0s distribution. And as part of the discussions before we started working on this, we were looking at kURL and we looked at K0s and K3s and different distributions and different options to try to figure out what the best bet was for us to be able to successfully deliver that embedded cluster experience. And so K0s has a couple of things going for it here. For one, it's distributed as a statically compiled binary with no host OS dependencies other than the kernel, which basically means that it can work on any Linux distribution out of the box. There's very little that you need to do to get the environment ready for the cluster to be installed because all the dependencies are shipped as part of that binary that's going to get installed. That just makes installation and pre-flighting and preparing the environment in advance, all that stuff is a lot simpler than kURL, where we had to ship host packages for each of the different operating systems that we supported and had to maintain support for those over time, as opposed to this, where we can support a much wider variety of operating systems automatically because pretty much any Linux distribution should work. And then the security vulnerabilities and other issues, a lot of these things can be fixed in K0s itself. We don't have to ship a host package or make a host level change because everything that K0s needs, for the most part, is shipped as part of it. And so it can update those things automatically as part of its update. So really, K0s ended up, for a few reasons, looking like the perfect solution for embedded Kubernetes. And I'll talk about 3 different reasons why that was the case. One is that it's lightweight and fast. So the application installation time isn't greatly increased by adding a cluster into it. So if your application takes 20 minutes to install, but the kURL installation takes 15 minutes, you've almost doubled your installation time by adding that embedded Kubernetes component to it. Whereas if the embedded cluster might take only 4 minutes to install, it's a much more marginal increase in the installation time, so it's a lot faster. And another benefit of that being so quick is that it's a simple development or POC environment that has all the prerequisites accounted for. So if you're looking to demo this to a customer, you don't have to worry about getting an existing cluster, getting all the prereqs on there, making sure the settings are correct. This basically ships as an appliance where it's like, just install this thing and it's going to have everything and it's going to work. You could also use it for development for the same purposes, getting everybody up to speed really quickly by deploying an embedded cluster along with your application. So that lightweight distro just makes the install a whole order of magnitude faster than kURL, which is ideal for all these different scenarios. Another reason it seemed perfect was that, as we've already mentioned, the elimination of host dependencies. So I won't dwell on this for too long because I've already said this, but makes it really widely deployable without requiring development on our part to support additional OSs. So you're going to get a lot more support, a lot more regularly, a lot more easily, which allows us to then focus our efforts on other things. And it also simplifies the installation, the pre-flight checks that we have to run because there's a lot less that needs to be there. So your customer doesn't have to do a lot to get it ready, which means we don't have to check a lot of stuff before the install happens necessarily. So just helps eliminate a lot of that preparation that goes into getting an environment ready. And then thirdly, K0s has support for automated cluster upgrades. So there's a feature called Autopilot in K0s that supports declarative Kubernetes upgrades. So you can create, if you were using K0s, for example, you can create a custom resource that tells K0s to upgrade itself to this version. Here's the location of the artifacts you need, all that kind of stuff. But so that feature enables us to offer one-click upgrades to unify the application and the infrastructure together, which is a lot more like an embedded cluster. That cluster is truly embedded if the upgrades are going to happen automatically and as part of the application upgrade, as opposed to what I described before, the experience with kURL, where technically you have one install command that installs everything, but you still have to operate and manage those pieces separately over time. So another thing that we've done with embedded cluster that is a great benefit over some of the struggles we've had with kURL is customizability. I mentioned before that the kURL as a distro builder that gave you flexibility to install different things. But oftentimes what you were able to do and configure was just the things that had been exposed as a part of curl. And so with embedded cluster, we have tested defaults that you can override. So this helps to reduce our testing matrix and know that we have an embedded cluster offering that has these specific versions and it uses these things, and we've tested that so we can ensure that that works. But that's overridable so that if you have scenarios where things need to change, you can do that. So one example of that is the ability to modify the k0's config to alter the Kubernetes installation itself. So if you want to change the bind address for the API server for a customer's environment, or if you need to modify the node port range that's available because Kubernetes might default that to ports 30,000 and up, and you need some lower port numbers like 40 and 443, you can do those things out of the box with k0's and with embedded cluster by modifying that k0's config. Another thing we've done is we deploy all of our extensions as Helm charts. So things like the storage provider and COTS, these are deployed as Helm charts, and we expose a way for you to modify those Helm values. So if you need to tweak, for example, something we've seen in curl where people want to change the memory limits or requests for Valero or an add-on like that. Instead of that having to be a feature request to Replicated where we have to expose those things and allow you to edit them or modify them, you can do those out of the box because we give you full access to the Helm values. And of course, we haven't tested all of these permutations, so there comes with a risk if you make a change that is incompatible or doesn't work for some reason. But assuming you're making sensible changes that are required for your application, you're able to do those things with this approach. We also support node roles, so you can create roles and add Kubernetes labels to those roles so that if your customers are creating a multi-node cluster, it's very easy for your customers to choose the right types of nodes, set up 3 database nodes and 4 application nodes, and those will have all the right labels automatically, so your workloads will get distributed to the right places. So it makes it very easy to set up a multi-node cluster. And then lastly, embedded cluster also gives you the ability to deploy additional Helm charts as part of the infrastructure before your application. So this was another thing that curl was lacking thus far, but we've seen customers that needed to deploy, let's say, something like Cert Manager, and it needed to be up and ready before the application came up because the app needed to use it to generate a cert or whatever it might be. So with embedded cluster, you can specify your own charts. They'll get installed and upgraded as part of the cluster before the application. And so that makes it a little bit more comparable to, say, an existing cluster scenario where you would expect the customer to already have installed Cert Manager, and that's a prereq for your application. And you can replicate that with embedded cluster by putting those prereqs into this Helm extensions so that they come with the cluster, and your application just goes on top of that. So it's less divergence between your existing and your embedded cluster installation methods. So in total, I think these changes help us to really deliver on the promise of an embedded cluster, where that cluster is really embedded into the application. It feels like a part of the application so that you can deploy it and update it as one, as an appliance is kind of how we've been referring to it. So now let's transition and talk a little bit about what's new with embedded cluster since the last time that we've talked. And I've got 3 new features that are all alpha or beta features that we've already had a number of different customers testing with. But I have some demos that I wanted to show, and I've actually just gone ahead and recorded these demos and put the videos in here so I can click through it, because with 3 different demos, I just wanted to make sure I had all of them here and there wasn't too much lag waiting for something to install or whatever. So I'll just click through some of these recordings and show you some key points as we go on. But the first demo I want to talk about is air gap. So obviously air gap is a really key feature of Replicated and has been for some time, but it was lacking in embedded cluster until relatively recently. And so obviously we needed air gap support for embedded cluster in addition to the online installation option. So let's flip through here and just see some of the highlights of the air gap installation. So first thing I'll note is that there's a new air gap bundle that's available for embedded cluster because we're updating both the app and the infrastructure together. So what we do is when you build an air gap bundle, we build the normal application bundle that you're used to building, which has your charts and manifests and images in it. And then After that happens, we take the embedded cluster artifacts that are needed for the version of embedded cluster that you have specified in your embedded cluster config. We take that stuff, we put it next to it, wrap all that up in an embedded cluster air gap bundle. So it's very similar to the app one, but it's also going to include the cluster stuff. And so this status, when it's built, shows me that I have built both of those bundles. This is one of those things we'll improve in time where there's just one status for both of them, and these links still apply to just the application bundle. But that status shows me that both of those bundles have been built. So I'm going to go ahead and, here I get the install instructions from my license, and the installing an air gap instead of online is very similar. So I'm going to copy that command to download the artifacts. But the difference here is that I'm just going to add right here, you can see this air gap equals true query parameter, so that when I download my embedded cluster binary and my customer's license, I'm also going to download an air gap bundle in that bundle so that I have all three of those assets. And you'll see later on when I untar this that I've got the installer and the license and the air gap bundle. And so then when I run my install command, it's going to be the normal install command where I run install, pass my license, but I'm also going to pass that air gap bundle. And so moving forward after this whole installation has succeeded, went a little bit too far, we can see here that if you've done an embedded cluster installation before, this is going to look very similar, but there's a couple of new things here. So one is that we're deploying a registry. So we need a registry for the application images to be stored in so that the embedded cluster can pull from that to deploy your application. So we deploy a registry. We push your images to that registry as well as some artifacts that are needed for embedded cluster. So install experience is still very much the same with just a couple of new elements added there that need to get installed. Now, if I move on a little bit farther, I can show what updating an air gap installation looks like. So much like you'd see normally in COTS, there's a button to upload a new air gap bundle. And after I've downloaded an update, so this is obviously a different version than what I'd initially installed, we're going to upload that bundle. And once that is done, let's see, that's going to give me a new version. Oh, there we go. A new version that I can deploy. And so that's very similar to the COTS experience you'd be used to where you come to the admin console and deploy. The difference here is that that bundle I uploaded had both my application and my infrastructure components in it. So by deploying these changes, I'm going to upgrade not just my application, but also the underlying cluster. And I think as this progresses, let me see. This might not show it, but at some point, when the cluster gets upgraded, you can see here my cluster state is upgrading. At some point, COTS is going to come down because it's getting upgraded. So you get a message here in the admin console that says that the cluster upgrade's in progress. And then when it finishes, you've upgraded both your application and the cluster in one. So now, let me just get past, yes. Now let's talk about multi-node HA. So another demo here, another new feature. For a long time, we've supported multi-node clusters in embedded cluster, or I shouldn't say for a long time, but for a little while we have. I think we demoed that at the last RepliCon. But what we didn't support was high availability multi-node clusters. So the first node of that cluster always was special because the COTS and Kubernetes data was stored on it, even if you added additional nodes. So now we have support for HA multi-node clusters so that that data can be distributed around to additional nodes to ensure that that data is durable and that the loss of a single node isn't necessarily catastrophic to the cluster as it might have been before if you lost that first node. So getting into this demo here, I've got a cluster set up that already has a couple of nodes. So in order to enable high availability, the trigger, the condition for that is to have 3 controller nodes available in your cluster. Once you're adding that third node or subsequent nodes, if HA is not enabled yet, you'll be asked if you want to enable high availability. Because we support a one-way migration here. You can move to a high availability cluster, but you can't yet move back to a non-high availability cluster. So we ask you if you want to make that switch. And in this cluster, I've already got 2 controller nodes. I've renamed controller to management in my embedded cluster config. So that's why these roles say management. But I've got 2 of those nodes already. And I'm going to get my join command to add a 3rd controller node to this cluster, and then drop down to the CLI and start running that install command. What is unique here is that I've passed this enable HA flag. So this is basically serving as a feature flag right now for HA clusters while some customers test this. We didn't want to change the entire multi-node join process yet while this was an alpha feature. So today, if you pass this enable HA flag, you can opt in to migrating to HA. And once this join is finished, it'll prompt me and ask me if I want to do that. So we'll just move forward here. And we get this message that tells us that when we're adding a 3rd controller node, you have the option to enable high availability, which will migrate the data and replicate it. And then, as I said before, it's a one-way migration. So once it's enabled, you need to maintain at least 3 controller nodes. So I'm going to say yes to that. That's going to start that migration. And eventually, that is going to complete. And just to show you what's happening behind the scenes, I'll drop down into kubectl here and list my pods. And a couple of things changed here. So one is you'll see that there's now 3 replicas of RepliCon, which is the database that COTS uses. So RepliCon is now running in a distributed mode to ensure that that data is resilient. And then this was also an air gap installation. So I'm running my registry, and the registry by default in the single node or non-HA multi-node case is backed by a persistent volume. And so when you migrate to high availability, we add a 2nd replica for the registry. So now I have 2 registry replicas, and we migrate the registry data from that PVC into an object store. So we use seaweed.fs in this case, and that's also running in a distributed mode. So now I've got seaweed.fs backing my multi-replica registry, and I've got RepliCon in distributed mode as well. So all of those changes help to ensure that that data is replicated throughout the cluster and make that first node not special and risk losing the cluster if you were to lose that node. And the last thing I'll demo here is disaster recovery. Now, if you're familiar with COTS and kURL, we've supported what we call our snapshots feature with Valero for quite some time. And disaster recovery is very similar in a lot of ways to snapshots. It's also based on Valero. We use Valero as the backup and restore mechanism in the disaster recovery feature. But we've made a couple of improvements here to make it work a bit better for embedded cluster, particularly because we're backing up and restoring that infrastructure in addition to the application. So walking through this, I think the first thing to note is that I need to enable disaster recovery for my application. So disaster recovery is not the type of feature that you can just turn on and it will work out of the box, because every application has different needs or requirements or processes for backing itself up and restoring itself. So there's a little bit of setup required for your application to make sure that the right things get backed up and restored in the right ways. So the main things to keep in mind are that you need to add the replicated.com/disaster recovery:app labels to any Kubernetes resources deployment or whatever it might be that you want backed up. So the presence of that label will ensure that that object gets backed up. And then the other thing to keep in mind is that any volumes that you want to be backed up. So if you mount a volume or a secret or whatever it might be into a pod, you need to use the backup volumes annotation from Valero to, this is a comma separated list of volumes that you're going to back up. So that ensures that both your objects via these labels and your volumes via these annotations are backed up. And in this case, this is where you get into the, application specific stuff. My app is a Postgres application, and so I'm using a pre-hook for backing up Postgres, dumping that data into a file, and then backing up that volume. And then on restore, restoring from that backup.sql file and bringing the data back that way. So that's specific to my application here, and each application will be a little bit different. But then as I move forward, what I need to do is enable disaster recovery for a customer. So this license field here is tied to embedded cluster because this is an embedded cluster only feature, at least for now. So you might have seen a second ago that when I disabled embedded cluster, this one went away. So these things like that. So these things are tied together because they're embedded cluster only. So by enabling that, I'm basically determining that this customer should be able to use disaster recovery and backup and restore. So a part of that is, if we look at my install command here, I'll see Valero is ready. So because the license that I installed with had disaster recovery enabled, Embedded Cluster went ahead and installed Valero as a part of that installation process so that disaster recovery would be set up and ready to go. So then the other thing that disaster recovery license field does is it enables this disaster recovery tab in the admin console. And here I can see my backups. I obviously wouldn't have any yet, as well as settings and schedule for those backups. So right now, disaster recovery supports any S3 compatible storage, whether that's AWS S3 or compatible object storage from another cloud provider or something you run on-prem. Any S3 compatible storage can be used for storing these disaster recovery backups. You put all your right settings in here and configure your storage settings. And then it also supports, much like our snapshots feature, scheduled backups, so you can take backups on a consistent frequency, and a retention policy to delete old snapshots, or old backups, I mean, after a certain duration. So in this case, let's see, I'll move forward to this backup that I took. So I took a backup here. That's by instance F5S6K backup is the name of it. Now let's show what the restore process would look like. So I'm going to drop to the CLI here and run my restore command, which is a new command we've added to the embedded cluster binary. So what I'll do is I'll just move forward pretty far here to show kind of the full state of the backup of this process. So I ran the restore command, and the first thing I'm going to do is enter my backup storage location. So the same stuff I put in the admin console, I have to give that to the restore command so that it can access the backups that I've taken. After that, we restore the cluster, Kubernetes, storage, and Valero, and then configure that backup storage location, which lets us query those backups and find that you have one restorable backup, which is that same one that I just took in the admin console. I say, yes, I do want to back up from here. We restore the infrastructure, which is your Helm extensions and things like that. And then we started restoring the cluster state. And what I showed here is that we actually support resuming a restore. So if you lose your SSH session and get disconnected, and then you come back and you reconnect, it'll detect an operation in progress and ask if you want to resume. So in this case, I resumed, cluster state got restored, admin console got restored. I have the opportunity to add additional nodes here. Move forward so that's a little more visible. I can add additional nodes if I'm restoring like a multi-node cluster. Once I'm done, type in continue, and then the restore finishes. And so this is a great way to be able to support that disaster recovery use case and situation for customers that are using embedded cluster. So all of those features are available today, and we've already had a number of customers testing them, but we'd love more feedback. If it's something that you're interested in, please let us know, and we'd be happy to work with you on it. So to wrap up, let's talk about what's next for embedded cluster. So we're excited to announce that in a few weeks, we're looking forward to general availability for embedded cluster. Unfortunately, it didn't quite time out to be able to announce that here at Replicated, but super looking at RepliCon, I mean. So super excited in just a few weeks to be able to announce general availability and be able to share that with everybody. But on the bright side, things that we've already seen a lot of really highly engaged customers and prospects who've been integrating their applications with embedded cluster and giving us great feedback on the current features and things that they'd like to see with embedded cluster. So really appreciative to all the many customers. It's really pretty astounding how many of our current customers we've seen getting their hands on embedded cluster and giving us feedback for this. So thank you all for helping make this as successful as it's been so far. And we're looking forward to continuing to work with you in the months and years to come to make it even better. And then, really exciting, we've even seen end user installation. So some of our customers have even already started taking embedded cluster to their customers and installing it into their environments, which is really excited to see, especially ahead of general availability. I think that shows the confidence and the excitement that people have around this offering. So real quick, let's talk about what are the keys to success? What are the keys to making sure that embedded cluster lives up to the excitement and delivers on its promise of being a great embedded cluster offering? So First, we're going to be monitoring installation success rates, ensuring that we are seeing an appreciable improvement over kURL and ensuring that we're seeing people reliably being able to install their application in an embedded cluster into heterogeneous enterprise environments. Something we've been saying internally is we're going to treat every support request as a feature request. So especially as we're starting to roll out embedded cluster and it's getting into new enterprise situations that it's never been in before, anytime there's an escalation to us, we want to look at that and think, how could we have avoided this? What feature or what pre-flight check or validation could we have implemented to have avoided this that we can use to help guide people or avoid these situations in the future? And then third, we want to keep supporting end users with feedback and guided processes and admin console functionality to help them be successful deploying and managing your apps in an embedded cluster. So if you've seen previous presentations, we talk about ClickOps, where we want to drive more of the end user workflows through the admin console. So anytime that's not possible, we want to think about how to take normal embedded cluster workflows and make sure that they are achievable through the admin console. So last thing here, upcoming features, a couple of things that are in plan. We know we want to support distributed storage with Rook because we have a variety of customer applications that need that distributed storage in a multi-node cluster, as well as a migration from kURL. And, we are still very committed to supporting kURL. It's not deprecated. Some people have been asking that. It's not deprecated. It's very much still an offering that we support and intend to support. But we're looking forward to helping some of our customers get to embedded cluster. And so if you are interested in migrating and want to work with us to help develop a migration that you'll be successful with, we'd love to talk about that. And then a few things that are under consideration, just to get them into your head, see if there's any interest or things that, if this might stir an idea in your mind. Auto scaling is something we've seen a number of customers mention as a limitation that prevents them from being able to use embedded cluster in production with their customers. So that's something we're considering, as well as SSH-based clusters, which this is particularly useful for large clusters. If you want to create a particularly large cluster and you don't want to have to manually go to each node, generate a join token, run that join command, and do that, n number of times. SSH-based clusters would allow us to just take a series of IP addresses and SSH keys and create a multi-node cluster automatically with a single command. And so as part of that, we're also thinking about extra large clusters, even up to thousands of nodes potentially. Embedded cluster intends to support out of the box some maximum number of nodes that we're testing that we know works reliably, let's say 10 nodes or something like that, where we're running tests. We know that 10 node or whatever it is, multi-node clusters work reliably, but potentially with the option to deploy much larger clusters for an additional fee per node. So that's another thing that we've also been considering. So that wraps up my presentation. Any questions? I would love to answer them, but thanks a lot.
We have a couple questions. So the first question, is it possible to download air-gap bundle with particular version?
Yes, it is. So let me see. Might be difficult. I'll try to go backwards. Basically, you can add the version to the URL that you use to download it. So like if I were to, let's see if I can find it here.
That makes sense.
Like here where I run that curl command, if I just put /1.2.3, that would download the 1.2.3 air-gap bundle.
Great.
And installer.
And then is there a way to run pre-flight checks before attempting to install K0s as part of the embedded cluster? So before installing the embedded cluster?
Yeah, so today we're actually right now adding our own host pre-flight checks that will run before installing K0. So that'll ensure that just our minimum requirements are met for sure. And then we do anticipate adding the ability for you to customize those and run your own checks that would happen before the cluster gets installed. So that should be coming.
That'll just be part of the overall installer. It'll run host pre-flight checks, correct?
Sorry, I missed the beginning of what you said.
Right. That'll just be part of the standard installer for a embedded cluster. Is it'll run host pre-flight checks.
Exactly. So right here in this output, we'd run host pre-flights first. And if they passed, then we'd move on to the install. Exactly.
Great. Will GA for the embedded cluster include full support for air-gap?
Yes, it does intend to.
Great. And we've already delivered most of that, correct?
Yep, it's air gap support isn't GA yet, just like the rest of embedded cluster isn't yet, but air gap does fully work and many people have tested it, and we'd love any more feedback people have, but it should be working.
Great. Okay. Thank you, Alex.